Hi, this is going to be the kickoff video for doing the Task 3 hypothesis testing that we've been also going through in class. Here I'm showing the assignment from Top Hat, and I wanted to show you how I am at least initially setting up all four hypotheses. So in Top Hat, it goes through what to do, and I've identified these 14 steps that you will be doing for repeating these for four different hypotheses. So to set that up, I recommend, it might not be a bad idea to take the two positive postulates. So I opened up a Word document here and I'm calling it Task 3 hypothesis testing. And in here, from the Task 2 Part 2 exploratory data analysis, where I found all the different postulates, some worked out, some didn't. And I had all the different types of visualizations. In here, I am taking the two I'm going to use for the analysis ready data set. So I'm just writing HT1 for hypothesis test 1. And below it, I'm writing the first thing, which was on the list over here, is state the positive postulate and supporting exploratory data analysis. So I went ahead and did this 4 times. So I put my first one for the analysis ready data set. I state my postulate that I see in the sample data, and now I'm going to begin to do inferential statistics to see if it applies to the entire population of organic food superstore customers. So here you see the supporting graph or table. So this one is the first one. And then what I did is I went ahead. Some of this is we already had started filling out in class. I'm going to go over that again. But I wanted to show you the general setup on this document. So then the second one, I went ahead and pulled in the second positive postulate on the analysis ready data set that I want to analyze. And in here, again, I just state what it is, and then the supporting graphs or data from our sample data. All right, everything below that is just the 14 points of what to include. And a lot of this may just be in Excel, which is fine, as long as I state that here. And then the third hypothesis test is the first one on the Millennials data set. So I put the millennial postulate here and the supporting charts and tables here. And then the second hypothesis test of the millennials is my 4th overall. So again, I wrote down what I'm seeing and the supporting data for that postulate. All right. Then what I did is I opened up a new Excel file. And down here at the bottom, you can see I've made 4 tabs, H1, HT1, HT2, HT3, and HT4. And what I did is I copied into the top of each one of these what the postulate is. So each one of these has the postulate, and then I went and got my Excel where I actually did all the exploratory data analysis, and I copied in here, as you can see, the exploratory data and the supporting. So for example, to do the side-by-side box plots, I needed to pull in the data that I had subsetted out between college and no college, college and no college, and on spending 2021, I pulled those worksheets into here by copying them over. So you can copy, let me see if I have another one open. Well, you can copy into another workbook. So you go to move or copy, create a copy. So you do this from your exploratory data analysis Excel file, and you can put it in a new book or in this book. Okay, so once I did that for all 4 of them, I'm now ready to begin this work. So let's go over to the first one, which we had started in class. And I'm going to do, there's basically going to be two types of um, hypothesis testing and that we're working on. We're either working in uh, numerical or the difference in means. You may set yours up as a single mean test. That may, depending on how you do it, that may be a little harder to make it useful to Catherine Hill, but it's possible it works just fine. I gave an example using a little research I did on the internet on average income. I did that one when we were doing the single mean t-test um, back a week ago or so. Anyway, for right now, I think the most common are the difference in proportions and a difference in means. So I'm going to start out by doing the difference in proportions. This is the hardest one. After this, they get a little easier. If you recall, we have, this is what we looked at in class. I did a pivot table and then I made this side-by-side bar chart off the pivot table. And so we can look at it over here in Excel. So the first pivot table was sex on the columns and race on the, sorry, I said that backwards. Sex on the rows, race on the columns. And I just did a count of the number of records that satisfied both of those. And then I, went into the value field settings and I modified it. And I did show the percentage of row totals because I wanted the population to be male and female, and I wanted to know the proportion of each race within, given that you're one or the other of these two populations. So given that, I saw this bar chart, and that's how I decided to focus on the blue bar, which is the proportion within each sex that were Black. And that's how I came up with my postulate. All right. So the next thing I said, okay, well, now because this has the word proportion in it, and your postulates are always going to have either the word proportion or mean. So this one's proportion. So I know that I need to go figure out what kind of test. And we did this already in class. We found out that we needed, well, first of all, we start out by converting what we're seeing into a hypothesis test. So identify the two populations. Population one is the female customers, and population two is the male customers. And you always want to make sure that if you are doing this type of contingency table, it's also could be considered a conditional empirical distribution table. That if your population are on the rows, you're going to have your 100% on the rows. If your population is columns, you're going to have 100% at the bottom in grand total in the bottoms. So it just depends on how you set it up. Okay. Then we also, because we're working with proportions, we're going to be dealing with the Greek letter rho. So we have row sub 1 and row sub 2 are going to be the proportion of Black customers in each of the populations. So row 1 is in females and row 2 is the proportion that are Black in males. And as I told you in class, when you write this out, you're looking now at when you're doing a proportion, you're looking at using the second categorical variable and finding the proportion that it is within the first, right? So when you write this out, you can just copy this and change everything that was a 1 to a 2 to make sure you don't mess it up. All right. Then we're going to convert the actual postulate. This is so tiny, let me make it big. We're going to convert it to an inequality. We have to do that in mathematical notation. So we're going to say, well, what we claim we saw back up here in plain English is that row 1 is greater than row 2. So that just becomes our alternative, row 1 greater than row 2, and then we subtract the row 2 from both sides, and we end up with our alternative, which then we use to derive the null, which is just the mathematical opposite. And now that we have our hypothesis, we have to identify what type of test is needed and what tail it is. So again, we use the alternative and we say this is a right-tailed, it's 2 sample. And in the flow chart that I shared with you in the slide deck from chapter 6, we can go through that. We'll go over and find the flow chart. You might have already printed it out. And so, by the way, in the slide deck is also just notes on how every single one of these different types of hypothesis tests. Okay, so the one where we're at was data categorical, number of samples, 2, compare proportions. So it's a 2 sample z-test for the difference in proportions. So we're going to capture that here. And then we're going to state the significance. We agreed on using 10%. And then the conditions for use or the test. So again, either you're referring to the handout on the, either you like the flow charts or we're going to refer to the table. And either way, let me get down to the tables. I think it's in here, difference between proportions. The requirements are right here, so we can do those. Here's the formula for the standard error. Here is the probability distribution that governs the test statistic. And then here are the Excel function or functions that you would want to use in this case. Okay, so let's go in and check the conditions for use. So in order to do that, we're going to need N1, and this is where we set this up, N1, and we point to the N1 and the N2, and then we have the row P bar 1, so it's the proportion, it's our proportion of Black female customers from our sample, and then for P bar 2, it's the proportion of Black male customers. Right, so then we're going to multiply these together and figure out if they're greater than or equal to 5, and that is what I'm doing here. I just ask Excel to tell me the answer for that. So again, it's just a way to automate the decision. So yes, it's true. They're both true. I could actually have a third condition that they both have to be true to use the test, but I'm going to skip that. All right, okay, I think it's pretty obvious. So now what we did is we want to get the numerator. And if you recall the numerator, hopefully you have this in front of you. I'm going to have to shrink this down. Okay. So here I'm going to just program that numerator in. So equals P1 bar times N1 plus P bar 2 times N2. Okay, and then the denominator, it is just the summation of the two. So right now I'm looking right here and I'm looking at this part, the denominator. Whoops, just the denominator, N1 plus N2. All right, so let's go in here and set that up, equals N1 plus N2. And then I'm going to get the, sorry, I keep saying plot area. Okay, I'm going to get the numerator divided by the denominator to get this factor called PP. So we're going to say equals the numerator divided by the denominator. All right, now we're going to get the standard error. And that is over here, this square root of PP times 1 minus PP times this part right here. So let's program that in. So you could do the square root as a second step and call this the standard error squared if you prefer, but I'm going to go ahead and do it this way. So I have PP times 1 minus PP times, and notice I have to put parentheses. I'm matching what I'm looking at in the mathematical equation. 1 divided by N1 plus 1 divided by N2. And then I need a closing parentheses for the square root. Now that I have that, I can calculate my test statistic, and I just made that a little bit bigger for you guys. Sorry, that's the formula for that. Oops, wrong spot. Sorry, got squished up on me. Where'd it go? Where'd it go? There we go. All right. So for those who want to see exactly what the formulas look like, there you go. All right. So back to the test statistic. All right. So the test statistic, because we know from the chart, or because you already have it memorized, it's going to, when we do a difference in proportions, we follow the standard normal distribution. So our test statistic is a Z, right, for the standard normal. And it's always, always, always going to have a similar form. It's the expected value, sorry, the observed value. So it's P bar 1 minus P bar 2. So it's the difference in our sample proportions minus the expected value from the hypothesis. And the expected value from the hypothesis is the number on the right here, 0. So it's P bar 1 minus P bar 2 minus the expected value of the difference in the parameters, and that is 0. So we are just going to subtract 0 from that. And so it doesn't really need to be there. So I'm just going to go then to the dividing by the standard error. All right. So that is my test statistic. And if I go over here to my hypothesis test, you don't have to actually do this, although you can. You can do it on another scratch piece of paper, but because it's a right tail test and it's a Z, it's not a bad idea to make sure that you actually have a value for your test statistic that is greater than the 0 because it's a right tail test. So we would expect the Z to be a positive number. So we see that it is positive. So far that is looking like we're on the right track. All right, now that we have this, what we need is this area in the tail. So we call that the p-value, right? So because I'm just going to say right-tailed to remind myself p-value. So the p-value with a standard normal, if you remember, and I don't know if this will let me draw or not, I think it might. So in Excel, all the functions in Excel for the normal distribution always want to give you the area to the left. And we want the area to the right. So we have, the only way we can do that is we're going to use the fact that the area under the entire curve, right? So the area under the entire curve is 1. So the area in the yellow part is 1 minus the area to the left of Z. So this is, and I think we went over this in class. Calculate the test statistic. Okay, so we did this. This was, let me just get this in here for everybody's notes. Z sub naught is equal to P bar sub 1 minus P sub 2. And we're going to subtract 0 from that. Well, we divide by the standard error. So that's that. And then we're going to obtain the p-value. And this is where I told you that in Excel, we have to do a little trick where we actually, what we want is the probability or the area under the curve when Z is greater than or equal to the 2.65 approximating. But we can't get that out of Excel. So we got to say it's 1 minus the probability that Z is less than or equal to 2.65. And that's equal to 1 minus, and how do we get the area to the left? It's that function norm, S for standard normal distribution. We put in the value on the axis, which is the 2.65, and we say true. All right, so let's go in and get what that is. So this part is where we're going to do this over here in Excel. So this is going to equal 1 minus norm S distribution, point to the Z, and then we're going to say true. Okay. So now we get the p-value, and we can state what our alpha is. It was 10%. And then this is where we just do is the p-value less than or equal to alpha, question mark. And this is where we just go ahead and have Excel do it for us if you'd like. I mean, obviously you can look at this and probably know the answer, but if you like to have it programmed, you can copy this from somewhere else maybe. And then the decision, right? And that's going to just be an if then else. So if, and we're going to point to that cell. By the way, I could have programmed that within the if statement. I just broke it out so that it's clear what's going on. So if that's true, what we wanted to say is, so if the p-value is less than alpha, then we reject the null. Now, some people may want to also add here and accept the alternative, but I'm just going to keep it short. If the p-value is not less than or equal to alpha, then we do not reject the null. Okay. So we've done all this. Let's come over to our Word document and document what we've done so far. All right, so we are perform the hypothesis test and state your decision. So we're gonna, we will say reject the null and accept the alternative. So what we thought we saw turns out to be applicable or to a 10% significance level. We can infer that it's true for the entire population of the organic food superstore customers. So we're going to interpret that back in English. So we say to a 10% significance level, the proportion of Black female OFS customers is greater than the proportion of Black male OFS customers. Okay. And then the final thing is to try to think about why this would be relevant or helpful to a marketing manager at organic food superstores. And this is the one where I told you um, I'm not going to grade anyone on reasonable, logical suggestions here. So there's many things that one could decide to do. Sometimes you could play to your strength, or you and gain more of your base and grow your base. That's one philosophy or approach. Another one is to build where you are lacking demographic or lacking, that you could view this as information for where to grow your customer base. So we talked in class about some options. So you only need to state one. So I'm just going to say develop market to Black male customer, potential Black males to grow this demographic in the customer base. Okay, so that's just one approach. All right, for the next one, we have the second hypothesis test is a customers who went to college had a higher mean spending in 2021 than those who did not go to college. And what I told you is you probably, if you had something like this, you would have categorical and numerical, and you'd have multiple box plots. So you'd have side-by-side box plots. And here I am going to focus on the second graph. I could do the first one. This is just a type of pivot table. And I am not really using this. This was just sort of an add-on optional. If you want to know how to do this, this is a very simple pivot table. Let me show you. So back in my task 2 part 2, where I was doing all the exploratory data analysis, I can go to the pivot table that has all the data. And here I'm looking at, in this example, we're looking at college and no college. So I'll use that. I'm going to clear out what's in the rows, and I'm going to get college in there. And I'm going to clear out anything from the columns. And oops, drag that away. And then I'm going to drag away anything from the values. So basically now I have just college, no, yes, and unknown. And then all I'm going to do is grab the spending 2021 and bring it down into the values. And it says sum of spending. Well, and this is definitely formatted wrong. Okay, so sum of spending is really useless because unless I have the exact same sample size in each group, the sum isn't, it could be very distorted. So I always want to change this to average. All right, so that's simply how you do this type of quick pivot table. It's just basically, it's a type of contingency table using the average of a numerical variable for your column. Okay. So now we want to define our populations. So population 1 is OFS customers. Let's see, no college seems to be on the left. And is that how? Well, we kind of stated it the other way around, so that's okay. Just have to make sure we don't flip that. OFS customers who did not go to college. population 2. Just come up here and copy this and say it's populate OFS who did go to college. So let's take that not part out. Okay. Define your parameters. All right. So in this case, because we are talking about the average spending, we are going to be referring to mu. So we're going to say mu sub 1 is going to equal the average spending in 2021 of population 1. So you could say population 1 here, or you can type it out and say OFS customers who did not go to college. And then I'm going to copy it because I want to make sure I am doing apples to apples. I want to measure the exact same thing in each population. So mu1 and mu2. All right, so so this is where we have to be careful about. Population 1 is those who did not go to college. So it looks like what we are saying for our alternative hypothesis is that mu1, and let me make this bigger, and I hope everybody can see this okay. What we're saying, right, is that mu sub 1, so the average spending of those who did not go to college is going to be what we're seeing in our side-by-side box plots, because the average, remember, is the little X in here. And because they were kind of close, that's part of the reason I added this little extra. Oh, this has nothing to do with this. That's right. This is ridiculous. Okay, forget that. I could grab the other one, but let me just skip it. Yeah, that's it, had satisfaction in it. Sorry, I didn't catch that. So back in here, this is the one I would want to grab. If we're going to do anything at all, we would grab this one. And then I have to format it and everything, but I'm not going to spend a ton of time formatting that, but I do see that the averages are different. I just wanted to confirm what the X values were. So 1479 is more than 1446. I don't know if it'll be enough to overcome variability in the data, but that's exactly why we're running a hypothesis test. Okay, so we're going to say it looks like the mean for those who did not go to college is less than the mean for those who did go to college, which is mu2, right? And just make sure everything lines up. Mu2 is the average of those who did go to college, and that is the X on the orange box plot. Okay, so we're good there. So now we convert this to the form where we're doing a difference in means. So mu sub 1, and we subtract the mu sub 2 from both sides. And this, but we maintain the inequality the same. So it's still a less than, now it's a less than 0. Right, so that is going to help us get the right structure for the null hypothesis. So the null hypothesis here is just the same thing, and if you want to make sure you don't mess it up, just copy it and flip the inequality to being the mathematical opposite. So if it's less than, instead it's going to be greater than or equal to. And okay. Now that we have that, we're going to identify what kind of test is needed. All right, so if we go back to our flow chart, you can find it. We're here in numerical. Number of samples is 2. We want to compare means. These are independent samples. So now we're stuck with this question. Is sigma 1 equal to sigma 2, yes or no? Well, we don't know what sigma 1 or sigma 2 are. What happens if we can assume that they are equal, we're going to have more power in our test to detect a difference. And since these are close together, it'd be nice to do that because we need the power to detect a difference of a smaller difference. If they're not the same, then we can use the different tests. Both of these tests are done by Excel. So I think the question that remains is, okay, we need to get some statistics on this data to decide if sigma 1 equals sigma 2 or not. So in this case, I'm just going to go to the data tab, data analysis. And you guys did this for part 1, task 2, part 1. So hopefully this would feel very comfortable. So the input range, I'm going to go with the no college folks. And I will say that there are labels in the first row, and I'm going to put the output right here. Oops. And I'll hit it. Oh yeah, summary statistics. All right, so that's going to give me this information right here for no college. You could go through and format a bunch of these to be dollars. Remember, you can't, the first 5 we can format as dollars. Then sample variance, that's dollars squared. Kurtosis, skewness, those are just numbers. Range is dollars, min max is dollars, sum is dollars. So we can also do those as dollars if we wanted to. Okay. And we got too big. Okay, there we go. All right, so that's what we have for no college. So let's get the statistics. And the one I actually care about is the standard deviation here, $55 for those who did not go to college. So let's see what the it is for those who did go to college. So again, data analysis, descriptive statistics. And this time I'm going to pick the yes college people. I'm going to do shift, control or command and down arrow key, get all my data in there. And then my output range needs to change. And I'm going to put that just right next to it, right here, I guess. All right. And then make this one a little bit bigger as well. Okay. So now we want to compare standard deviations because that is our S1 and our S2, which is the closest we can come to a guess based on our data of what sigma 1 and sigma 2 look like. Well, 55 versus 67, that's really different. So I'm pretty sure we're going to be down here in the we don't have any reason based on this to believe that sigma 1 equals sigma 2. So that's going to force us into the less powerful test, but it's sort of the fail safe. We're not going to assume anything. My first job out of college, I worked for, I was a management trainee at a company called Sprint. You may remember was a cell phone company. And the secretary used to always say, when you assume something, you make an ass out of you and me. I'll never forget that. Anyway, okay. But sometimes in math, you do have to assume stuff. Okay, so we're not going to assume it in our case, though. So we're going to go back to our document here and state what kind of test this is. All right, so we will say, first of all, based on the direction of the inequality, it's a left-tailed. It's a left-tailed to sample test, assuming unequal. We're assuming unequal standard deviations, but Excel calls it, considers the square of that, right? Which the square of the standard deviation is the variance, unequal variances. All right, so this is the test that we've identified is what we're going to need to use. And just to keep us all straight, right? It's a left tail test. It's going to follow the t distribution. We're going to have a t test statistic. And we're going to need to get the p-value in the lower tail. And because it's a left tail, we expect the test statistic to be a negative number when we calculate. So that's our sanity check to see if we are, if we make sure we didn't flip populations when we input them or anything weird. Okay, so what significance level? All right, so this one, we're going to, again, people who go to college or not go to college, that could be a big, that could really impact marketing direction, I think, and how you go about doing things. So let's make this one a 5%. You can choose what you want. Just think about why. I probably should have you state why you choose it, but just so I know you've kind of thought about that this is the risk and what it entails and what it means. So we're going to use an alpha of 5%. State conditions for use of the test. So for a t-test, if you remember, and you can look back to the slides, really the conditions for use is that if either of the sample sizes are less than 30, we have to have normally distributed data. So we can say N2, N2, N1. No, I actually meant N1. The people who did not go to college. N1 is equal to 27. And I got that by looking right here at the count. Right, so I'm looking at count on no college. That was population 1 is 27, which is less than 30. So that means that we need to be sure that the no college data that are sample population 1. Actually, let me just delve a little deeper into the theory. We actually need that population 1, that X, which for us is the average, is the spending, not the average, but the any spending from all the customers. So spending 21. We need that to be normally distributed. In population 1. Right. So the way we do that is we would do a normality plot, a QQ plot. Hopefully you cover that in your, or you may remember covering it in your first statistics class. And we are going to not require, I'm not going to require that. So we're going to assume this is true. And that you can do the same with yours. A QQ plot is something that is very standard and very normal to do. For some stupid reason, Excel doesn't have it pre-programmed in their plots. Well, unless they change that. Yeah, I'm looking at what's in here. I don't see it. So it's called a normality plot or a QQ plot. And most other software like Tableau, which is probably what you're going to be using if you keep doing any kind of analysis, you'll probably want to learn that. But you need to know Excel, and I don't want you to have to learn 2 softwares, so I'm sticking with Excel. So we're going to have to assume that's true because we can't pop the data. We should be able to pop the data and have it do it for us real quick. It's not hard to code. So that's frustrating to me. But anyway, we're going to assume that's true. The second condition for use is that because N2 equals 153, and that is greater than 30, greater than or equal to, then we can use the test. As long as there's no outliers. And we took them out, so we don't have any in this call. We made that decision in a meeting with Catherine Hill when we were talking about the outliers in the spending 2021, which actually would have really impacted this if we had to do a sensitivity analysis. If we had decided to keep, because that was the variable that had outliers, if you recall, and that were too high of a percentage, they were more than 5%, so we couldn't just choose to delete them. And so we could have possibly at this point had to run this analysis twice with the data with the outliers and the data without the outliers. And the data with the outliers, we would have needed to do a different type of test because the t-test doesn't really do so well with outliers. Okay, so now we're going to have to state the form of the standard error. And we can just say this will be done in Excel. And calculate the test statistic. All this part right here is going to be done in Excel. So just let's copy that down. Oops. Oh well. We're going to obtain the p-value in Excel. I don't know why this did this. Okay. Formatting in Word is sometimes a pain in the butt. It wants to do too much to help you. I don't want it over here. All right, so let's go and do this t-test over here in Excel. I'm going to just make the Excel bigger. All right, so I'm going to go ahead and go into the data analysis, scroll to the very bottom, find the t-test to sample assuming unequal variances. And you may choose equal variances if these values are kind of closer to each other on your postulate when you do something like this. And the little GUI box here, GUI stands for graphical user interface, which is the little box we're going to type things into, is going to look the same. So it's just going to be different math calculations in the background. So let's get variable 1. We're going to code with the no college for that. And because I changed my heading, I can go ahead and use this. And variable 2, I'm going to, again, choose this. The hypothesized mean for our purposes in our class is always going to be a 0, the mean difference, because I'm not teaching, we're not doing anything more fancy than that. I did have labels at the top of my data. I have an alpha 0.05, and I'm going to select where I put it. Let me scroll up. I think I'm going to put it right here. All right, so let's just say okay. All right, I need to format this just a little so I can read everything more carefully. This data is money, so I'm just going to format the ones that matter, the mean, and I'm going to put a line that separates the values that are for each sample versus what's coming out of the test. So we see our t-statistic, sorry, our test statistic. And it's a negative 2.78, which is great because that matches up with what we expected. We expected a negative t-value. And the degrees of freedom were 41. So this is where more difficult math was involved, and it calculated that for us. And then our one-tailed, so we have a one-tailed test here. That's our p-value. So this is where we're going to type in the alpha. And we had decided to do a 0.05 alpha. Now I'm just going to come back over to hypothesis test one and copy this code that I already programmed in. Oops. To hypothesis test two. And I might need to shift things around a little. I need to make sure the p-value is pointing to the p-value. So let me click on that cell. Notice it's pointing to this number, which is wrong. So I'm going to drag it to the p-value, which is a probability of a t distributed variable and less than equal to our test statistic. And we get that's true. So I get reject the null again. So here, the decision is we're going to reject the null. And then that means we're going to accept the alternative. So let's, oops, not just HA, I want to say accept. We're going to accept the alternative. I hope I did that up above. Oh yeah, okay. All right, so we're going to accept the alternative. So let's write that back in plain English. So we're going to say that to a significance of 5%, the average spending in 2021 of OFS customers who went to college is greater than, so I'm just writing the alternative claim, is greater than, oops, who did not go to college. All right, so now we're going to think about a strategy that could be used by Catherine Hill and company from this result. So again, we realize that spending is one of the most, how much a customer spend is directly related to the revenues, which was what Catherine Hill is concerned about. She's not focusing on reducing costs. She's focusing on increasing revenues. So spending is probably of all our variables the most directly related to revenues, right? So because it's what the customer spent, which means it's the revenues to Organic Food Superstore, in case that wasn't totally obvious. Okay, so the revenue, we could say that she could, again, either play to your strength or try to grow the area that's lacking. So one strategy could be, let me just pull a bullet. And you can add, you might come up with your own here. I guess I would say focus marketing on college educated people, grow customer base. They will lead to greater revenue average than non-college educated. All right, so that would be the end of my second hypothesis test. My third hypothesis test is asking if millennial customers that were somewhat satisfied spent more on average in 2021 than millennial customers who were neutral. And part of the reason I chose this one is I did a pivot table using satisfaction and average spending. I could have also done, because this is at one categorical, one numerical, I could have also done multiple box plots like I did over here on the left. I started out this way because I think that sometimes this approach is a little faster. This is the one that you do with doing that alternative kind of contingency table that I was talking about. So in here, there's a lot of different postulates I could have pulled out. So I wasn't sure which one to pull out. So I actually added to my pivot table the count of satisfaction because I wanted to focus on which of these bars actually came from the largest sample size. Because the greater the sample size, the greater the power, all things being held equal. So I noticed that Somewhat Satisfied has 29 records. So I want to focus on Somewhat Satisfied here. And I wanted to make a statement about Somewhat Satisfied versus one of the other bars. And the one that I chose was neutral because it looked like it was the biggest difference between them. So I am saying the millennial customers that were somewhat satisfied spent more on average than millennial customers who were neutral. Now, I actually think that in the real world, I'm not asking you to do this because I know it's a lot of extra work. In the real world, I would actually group. I'd create a new variable where I would bin somewhat satisfied and very satisfied. And I would bin very dissatisfied and somewhat dissatisfied and see how that new variable that had those binned compared to each other, because I think that would be more useful. But for the purposes of teaching, I don't want to have you have to do so much extra work. This is where things evolve as you dig into it. You can very, very frequently find that you need to create another new variable, and then you have to go back and, kind of trickle it through all the work we've done so far, creating a new variable, getting the statistics on the new variable, or the frequency table, whatever. This one would be categorical, so it'd be frequency and relative frequency, all of that. So anyway, I'm not having you do all that work, but hopefully you're following what I'm saying, that this is somewhat of a cartoon example, that I'm just wanting to pull data out to use for a positive postulate. But I'm trying to make it as robust as possible. So by robust, I mean like that it's not likely to be as influenced or biased because the sample size is so small. Okay, so now I'm going to define my populations. And so population 1 is millennial OFS customers that are, I think we decided I can say somewhat satisfied. Well, just to keep everything straight, since neutral is to the left, I'm going to go with neutral as my population 1. And again, not to make things overly long, but technically I'd want to say that report their satisfaction level as neutral, right? And then population 2 is going to be millennial OFS customers that report their satisfaction level as very satisfied. No, somewhat says as are somewhat satisfied. All right, now that I've done that, we're talking about the average spending. That's a numerical variable, and we use the word average when we talk about numerical. So we're going to be using, again, mu1 and mu2. So mu1, oops, is going to equal the average spending. So this is where I refer now to the second variable, 2021, of population 1. And at this point, oops. So at this point, it's going to kind of follow along the way the previous example was set up. I need to come over here to my hypothesis test 3. I need to pull in my subsets of my columns of my data. So I need to get data on spending 2021, but from the millennials now, and it needs to be broken up by, I need to pull the data for the neutral and the somewhat satisfied people. So let's just get you started on how one would do that. So I'm going to create that data. Just need a good space for it. I guess I'll put it right here. And I'm going to say spending 2021 values or data or whatever. And we're going to say population 1 was neutral and population 2 was somewhat satisfied. So we need to go get the spending 2021 data. So this would be from your part 2 data. So we can go to the ARDS full data. And in here, I'm going to go to satisfaction. Actually make sure there's nothing. I want to clear any filters before I keep going. Let's pick the neutral data. And then I'm going to come over to spending 2021. I'm going to go to the first value there, and then I'm going to use shift on a Windows shift control, on a Mac is shift command and the down arrow key, all 3 at the same time will give me this data. I'm going to copy this data over to neutral. Okay, so I can see that I have that data there. Now I'm going to come back over to my ARDS data. I'm going to clear that filter, go back to satisfaction, and this time I'm going to pick somewhat satisfied. And I'm going to go to the first cell in my spending 2021, and I'm going to again get all this column of data. I'm going to copy it, and I'm going to put that next to the neutral data here. And the amount of data should be different. We knew that. So now we have that data side by side. And now I'm going to need to run statistics on both of these because I'm going to need to compare the sample standard deviation, just like I did for HT2, to decide which test I'm going to need to use. Okay, so I'm going to stop there for the video. I will complete this work so you can check if you want to continue to follow along with me, or you can go and do your own. It's going to be very similar. The fourth hypothesis, which is my second one on the mills, is using proportions. So this is going to be like my hypothesis test 1, which was looking at the difference in proportions. And again, everything I'll finish up this document and upload it, but I'm not going to include all that in the video because it's just repeating the same type of procedures.